Hi, this video is a brief summary of what we talked about radical halogenation of alkanes. So this is a different type of mechanism than we talked about for conversion of alcohols to alkyl halides. In this case, we're going to take an alkane and convert it to an alkyl halide by adding X2. In this case, again, X is equal to either chlorine or bromine. And we have to do this reaction in the presence of something called a radical initiator. And in this case, we're going to use light or peroxides to initiate radicals to form. We get the alkyl halide and an acid halide as products. So whenever you do a radical mechanism, there are three main types of, or three main steps to the reaction mechanism. So the first step is going to have to be initiation. Initiation steps produce radicals, and they require the radical initiators, the light or the peroxides. So for this type of reaction, where you're taking a dihalide and you're using it to halogenate an alkane, the first step to this reaction is for either light or the peroxides. I'm going to put either. To promote homolytic bond cleavage. And that means that this bond is broken evenly to either side. And so my result is two of these halogen radicals. So these two electrons here used to be the bond. Notice how I'm using fishhook arrows here, arrows with only one arrowhead, to show that one electron is moving in either direction. So that's different than the two-headed arrows that I normally use for polar reactions. So after this initiation step happens, the next step is going to be a propagation step. In propagation steps, radicals go in and react with non-radicals, and the result is usually a product and another radical. So radicals go in and come out of this step, or these steps. There can be multiple propagation steps. So in this case, I actually have two different propagation steps that are required in order to form the products. So the first one is for my halide radical that I just produced is going to react with one of the carbon-hydrogen bonds. So in this case, I forgot to say that my example that I'm using is CH4 plus X2. It's going to go to XCH3 plus HX. So I'm using methane as my alkane in this case. Now, this hydrogen-carbon bond is going to be broken, and the halide is actually going to bind to the hydrogen. So I'm going to use my fishhook arrows to show that one bond from hydrogen and one bond from the halogen are going to come together and form a bond. But there's still one electron left in this bond, and it's going to be left on the carbon. So again, I'm breaking my bond in a homolytic fashion, and I'm going to get my halide now attached to my hydrogen in a new bond, and the carbon is left with one electron. So I have now a new radical. I put a radical in and I got a radical out. That's a key part of the propagation step, and that defines this as a propagation step. Now, I formed one of my products, the HX here, but the other product hasn't formed yet. And here, in the next propagation step, I'm going to take this and I'm going to react it with a non-radical to make my product. So I'm going to call this propagation step B, and I'm going to take this methyl radical and I'm going to react it with another equivalent or another molecule of the X2. And this radical is going to react with this dihalide and make a new bond. So I'm breaking this bond in a homolytic fashion. One of the electrons is going to go and combine with this electron to make a new bond, and the other electron in this bond is going to be left on the second halogen. So now from this, I should get my alkyl halide with a new bond between the halogen, and I get a new halide radical out of this step. So once again, I put a radical in and I got a radical out. And now I've got both of my products. I have my acid halide product and I have my alkyl halide product. I'm gonna, the last part of this reaction, or the last step for any radical mechanism is a termination step. Termination steps take two radicals and combine them to make non-radical species. And so there are many possible termination steps that could happen. In this case, I actually have three possible termination steps from combining my potential radicals in any different way. So I have halide radicals. I could combine two of those in a radical way. So here I'm going to take one electron from each of the halogens and make a new dihalide bond. Another way I could combine radicals is I could take the halogen radical and I could combine it with the methyl radical that I produced in my propagation step. So now I'm forming a bond between the halogen and the methyl group. And the last possibility that I can think of is to take two of these methyl radicals and combine them. Now notice, this is a new product. This is not something I wrote up here in my reaction, and it's a potential side product from these termination reactions. But in general, most of the things that form in this reaction are going to come from the propagation steps. What I didn't mention was that this initiation step happens and it produces only a small amount of these radicals. So at any time in solution, there's a very small relative amount of radical species compared to the non-radical species. So it's much more likely that a radical is going to run into another non-radical, like in these propagation steps. It's much more likely than for two radicals to run into each other. And these chain reactions that happen in the propagation steps are going to give you probably 99% of your product for most reactions. And these termination steps don't give you very much at all. So you need to know about the termination steps and you need to know about the possible products just in case you see them, but feel safe in assuming that most of your product is going to come from the propagation steps. So radical mechanisms in general, 3 steps: initiation, propagation, and termination. And you should be able now to draw a general reaction and a reaction for a specific example. So make sure you practice with the problems in your textbook and on your lecture review.